like this. Find angle A and B. A lot of you were, you didn't know how to do this yesterday, but really we actually did learn this yesterday. So we're asked it differently than how I asked it yesterday, but it is the same thing. So find angle A and B. Well, okay, which angle should we find first? It doesn't really matter. I'm just going to go with finding angle B first, so I put a theta there. Okay, now don't we know how to do that? We did learn this yesterday, right? So we know from theta we have the adjacent side. Now some of you guys need to get in the habit, some of you that are struggling significantly with this stuff, before you start doing this, everybody, you could write in by the 3 that that's the adjacent side, right? And and adjacent side, and then this is the opposite side, right? And this is the hypotenuse. So if you need to write those in for yourself, it wouldn't hurt. Anyways, okay. So from theta, we have our adjacent side and our hypotenuse. So then you should have your 3 trig ratios right in front of your eyeballs so you can look and easily see. Which trig ratio has adjacent and hypotenuse? Cosine. So we'll use cosine of theta. So write it down. I'm using cosine of theta is equal to the adjacent side over the hypotenuse. And then you put in everything you know. This time we have theta still, so we have cosine of theta is equal to adjacent, which is 3, over hypotenuse, which is 5. And then from there, we're solving for angle theta, which is angle B, right, everybody? So then we just have to undo cosine, and we know we can undo cosine. Now, because we're solving for an angle, we use the inverse. That's the only time we use an inverse is if we're solving for an angle. So we're trying to solve for an angle, so we will take the inverse cosine. We have to do it to both sides of the equation. Then inverse cosine and regular cosine cancel out. That's what inverses do. So that leaves us with theta on the left is equal to cosine inverse of 3/5. And you type it into your calculator. Second cosine. So everybody practice. Not just watch everybody else. Second cosine of 3 divided by 5. 53.1, right? So theta is equal to 53.1 degrees. Well, if we know angle, so now I'm going to go back up here. I'm going to erase this. I'm going to write it in just for my own liking. This is 53.1 degrees. And then from there, can't we just find angle A easily? 180 degrees. So angle A is 180 degrees minus 90 degrees minus 53.1 degrees, right? Everybody?
Yes.
So 180 minus 90 minus 53.1, 36.9 degrees. Okay. Any questions on that? Okay, hopefully it'll be easier for you guys to see this a second time today, because yeah, this is difficult stuff. Okay, so I want to do, how many of you would like to just see it one more time solving the triangle when you're given an angle? How many, it wouldn't hurt if we went through it real quick. So are you good to see it one more time real quick? You don't need to take notes, we saw this yesterday, but maybe we should see it one more time, and then I really think when you see it a second time, you'll say, oh, yeah, that was easier than yesterday. So when we're solving the triangle, the first thing we do is find all the missing angles. So we have 33 degrees. Once again, we can find angle B very quickly. 180 degrees minus 90 minus 33, right? 180 minus 90 minus 33, we get 57 degrees. So everybody should at least be able to do that step. On the test, if anyone misses that, that would be really, really foolish, because we know how to do that. So then from there, now watch carefully. From there, we need to find side B, right? And I write it as a little letter, because sides are written as little letters. And we need to find side A. So I'm going to set up a trig ratio to solve for each of those sides. Now, I don't care if you use 33 or 57. Choose one and circle it. I'm going to just go with 33 degrees. That is my theta. We're all comfortable with that, right? So then from there, I'm going to set up a ratio using a variable and what we know. So we know the hypotenuse is 45, so we'll use 45 for sure. Let's solve for side A, which is opposite. So we have opposite and hypotenuse, right? So for A, we're going to use opposite and hypotenuse would be sine. So I'm going to solve for A. Sine of theta is equal to opposite over hypotenuse. Then you plug in everything you know. Sine of 33 theta is 33 is equal to the opposite, which is A, over the hypotenuse, which is 45. Then from there, notice we only have one unknown. We just algebraically get A alone. So we need to get rid of our fraction. So because 45 is on bottom, we're going to multiply both sides by 45. Then look at your equation. Is A solved for? Yeah, it is, right? So A is alone, so you're done. All you have to do is type it into your calculator. So type it in. 45 sine of 33. Somebody tell me what you get. What was it, sorry? 24. So 24, did somebody else get that too? So 24.5 is equal to side A. So this is 24.5. Now I would suggest not using the Pythagorean theorem because you'd have to use the full decimal. I'm just going to quickly set up a different trig ratio. That wasn't that hard, guys. Here we go. I'm going to circle 33 again. I'm going to circle 33 again. And then I'm going to use the hypotenuse because I don't want to use the full decimal. I'm going to use the hypotenuse and the adjacent side. So hypotenuse and adjacent. Which trig ratio, and we're solving for B, which trig ratio uses hypotenuse and adjacent? Cosine. So I'm going to set up cosine of theta is equal to another hour. So adjacent over hypotenuse. Then we put in everything we know. Cosine of 33 is equal to the adjacent, which is B, over the hypotenuse, which is 45. And then we'll just solve for B, algebraically multiply both sides by 45, because 45 is on bottom. If B was on bottom, we would multiply both sides by B, right? Divide those out, and B is isolated. Once again, you just type it in your calculator. 45 cosine of 33. 37.7 is equal to B. And then we didn't have to worry about any rounding errors. And honestly, that should have been just as easy for you as the Pythagorean theorem. It just takes a little bit of practice. But don't let these freak you out, guys. You got it. You've got it. Okay? Any questions on that? Was that easier today? Because it was hard for us yesterday, you know? And it is hard. I'm not going to say it was easy. But hopefully seeing it a second time is easier. Okay, awesome. Let's get to today's lesson then. No, I mean not today's lesson. Sorry, finishing up this. Didn't mean to say that. Okay, let's do number 6, and then I'll have you finish the 2 last problems on that worksheet, and then you can hand it in. So I'll do number 6 with you. So here we go. We're given this right triangle, and we're asked to solve the triangle. So the first step, no matter what, is to find all missing angles. So our first step is to find the angles. So I need to find angle A, and I need to find angle B. Now, this is very this is exactly like that first example I showed you. Well, which one do you want to solve for, A or B? Let's put in a theta somewhere. A, all right. So I put my theta in at A. And then from there, I set up a trig ratio based on what I'm given to solve. I'm given opposite and adjacent. So we're going to be using tangent, right? So tangent of theta is equal to the opposite, which is 15, over the adjacent, which is 6.9. And then from there, I only have one last step to get to solve for the angle. Now remember, when you're solving for angles is when you'll use the inverse. So from here, I'll do the inverse tangent of both sides of my equation. So then inverse tangent and tangent cancel out, leaving us with theta on the right, which is awesome because now we've solved for the variable theta. So theta is equal to tangent inverse of 15 over 6.9. Type it in. Tangent inverse. 65.9. So theta is 65.3 degrees. So guys, I know that angle A is 65.3 degrees. Well, now isn't angle B easy? We don't even need to use a trig ratio. Now we know 2 angles of a triangle, so we can go ahead and solve for the other side by taking 180 degrees minus 90 minus 65.3. 24.7. Does everybody understand that angle B, how I got it? So that one was pretty easy. 24.7. We actually almost like these ones better because then from there, look at our sides. Do we have 2 sides? Yeah, so we can use the Pythagorean theorem. Why not? And did it start with decimals? Yeah, so we can use decimals. So now to find side C, we'll set up the Pythagorean theorem, which is side 1 squared plus side 2 squared is equal to the hypotenuse squared. Put it in the correct spot. Don't make that error of not putting it in the correct spot. So side 1 and side 2 don't matter, but the hypotenuse has to go on the right side of our equation. So we're going to be doing 6.9 squared, which is, I chose to be side 1, but it doesn't matter. You could have done 15. So then plus 15 squared is equal to our hypotenuse, which is c squared. Then solve for c. Type it in your calculator. 6.9 squared plus 15 squared. Hit enter. We have 272.61 is equal to c squared. Last step to get c alone, square root both sides of the equation so that our root cancel out our power, because we want c, not c squared. So then you'll take your calculator, the square root of 272.6, 16.5. 16.5 is equal to c. 16.5. Is everybody comfortable with that one? So side C was 16.5. And there's our answers. And remember, your triangle should make sense. So if your smallest angle is not across from the smallest side, you've done something wrong. If your medium angle is not across from your medium side, you've done something wrong. So you guys, it's a good way on the test to check and say, does my triangle make sense? And if not, go back and start over. All right, so now I want you to do 7 and 11 so that we can move on to today's lesson. Ready, set? So we're going to be doing applications of right triangle trig. Now, these are story problems, but they're actually easiest problems we've done this whole unit. But you just have to be able to draw a picture. And guys, you draw the picture exactly how it says. So these really are not too bad. The hardest part is getting students to be able to draw a picture. So everybody listen closely. Before we get started, these are 2 new things that you have not taught, we've never talked about, and you have to know them. I'm telling you, you will see both of these on the test, okay? And you'll see them today too. So angle of elevation. So guys, this is how angle of elevation works. Here I am standing. Everybody pay attention because this is very different. And you have to know the difference. And these are the hardest things right here. All right, so angle of elevation. Here I am standing. If I look up at that flag, does everybody see me? My eyeball started from the ground and I look up at the flag. Does everybody see how it looks like this? Yeah? So the angle of elevation starts at the ground if somebody's looking from something from the ground up. So angle of elevation is right here. Does everybody see that? Oops. Sorry. Let me get the pen going. So this is our angle of elevation. So it starts from the ground looking up. Angle of elevation. Do you see the angle of elevation here? Now look, isn't this a right triangle? Yeah. Okay. Interesting. Now the difference between angle of elevation and angle of depression. So now I was on the ground and my eyeball started from the ground looking up. That created our angle of elevation. Now if I'm up in the air, like for example, if I'm in a hot air balloon, my line of sight starts by looking out, right? So now I'm up in the air in a hot air balloon. Does everybody see the person? Their line of sight starts up, and if they look down at an object, does everybody see how that creates the angle of depression? So you're up here and you look down at something. This is creating the angle of depression, the distance from where your eyeball started to what you look down. Does everybody understand angle of depression? Okay, now here's one thing to know about angle of depression. This is the one that is most missed on the test, and most students, they misinterpret. Angle of depression does not fall in your right triangle. Do you see how this down here is the right triangle? So this angle, the angle of depression, was created up here. It did not fall into the right triangle. But it does have a 90-degree angle right here. So you can find angle theta inside the right triangle by taking 90 degrees and subtracting your angle of depression to get theta inside the right triangle. Because we can't use the angle of depression up here because it's not in the right triangle. So you'll take your angle of depression, you'll take 90 and subtract it. That would be your angle right here, and that's what you would use as your theta, because you need to use an angle inside the right triangle. Does that make sense, everybody? Okay, so also fun fact for you, a lot of students actually, I hope this doesn't confuse you, but a lot of students like it. If this is our angle of depression up here, do you see how we have 2 parallel lines right here, the ground and then where my eye started? So, and we have this transversal. So this angle and this angle are alternate interior angles, right? So this angle right here is actually the same as the angle of depression. So you could actually take the angle of depression, flip it down here, and then isn't this angle now in our right triangle? Yep, and so then you can just use that. Does that make sense? Okay? So as long as you understand those things, it's not too bad. Okay, let's get going. So here's my examples, guys. I don't want you taking notes. I want you watching and paying attention to little details. The hardest thing is drawing the picture, but it really is drawing exactly how it says. And then from there, the trig is easy. So it says, everybody pay close attention to the little details. Don't just minorly watch and say, oh yeah, you're making sense, I'm getting it. Really grasp what I'm doing here. So it says, a girl is standing 120 feet away from the hotel. As she looks up to the top of the building, the angle of elevation is 37 degrees. So find the height of the building. So I'm going to go through and just piece by piece draw a picture here. So it says, a girl is standing 120 feet away from the hotel. So I'm going to draw a hotel, everybody. Okay? Does everybody see the hotel? Now I'm drawing a girl who's standing 120 feet away. Wouldn't that mean that this is 120 feet right here? Does everybody understand that? It really is drawn exactly how it says. Okay, so it says, as she looks up to the top of the building, so her line of sight is looking up, right? Ding, 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 ding. Isn't she looking up to the top of the building? She's looking up to the top of the building, and it creates an angle of elevation, which makes sense from the ground up. It's 37 degrees. So this is a triangle here, and this angle is 37 degrees, right? We talked about that just a second ago. Angle of elevation, looking up. Does everybody see how that's my angle of elevation? Now it says, find the height of the building. So guys, it's literally, what are we finding? The height of the building. Does everybody understand why the X would go there? So then from there, we just use trig, and it's easy. We have this angle. We're going to be using the opposite and the adjacent side. Opposite and adjacent is tangent. So I'm going to be using tangent of theta is equal to opposite over adjacent. And then I plug in everything I know. Tangent of 37 degrees is equal to the opposite, which is x, right? Over the adjacent, which is 120. And then algebraically, we're just solving for x. So we multiply both sides by 120, right? Because it's in the bottom. And then x is solved for. That is the height. Type it into your calculator. 120 tangent to 37. 90.4. So 90.4 is equal to x. 90.4. So 90.4, and were we talking feet, inches, what? Feet. So 90.4 feet, and that's our answer. Now, was that probably one of the easiest problems we've done? Yeah, but it's just drawing the picture. Students just seem to have a hard time with that. But do you see how it's literally drawn exactly how it says? There's no tricks. There really isn't tricks. Okay. Let's do another one. So it says, a boy is walking on a leash that is 22 feet long. Did I spell leash wrong?
No, you said a boy is walking on a leash.
Oh, a boy is walking on a leash. A boy is walking a dog on a leash that is 22 feet long. The angle from the ground to the leash is 17 degrees. How tall is the boy, and how far is the dog away from the boy? So we just draw a picture, piece by piece. Don't look at the whole thing. Go in pieces. A boy is walking a dog on a leash. So here's a boy walking a dog on a leash, right? Here's my dog. It says the leash is 22 feet long. Does everybody understand how I drew that? The angle from the ground to the leash, so here's the ground, right? Think of it literally. Isn't this the ground? The angle from the ground up to the leash is 17 degrees. Does everybody see how I did that? It's literal. From the ground up to the leash is 17 degrees. So how tall is the boy? Let's just answer that question first. I'm going to put an X there. So now we need to set up a trig ratio. So from 17 degrees, we have the opposite and the hypotenuse. So we're going to be using sine of theta. So sine of theta is equal to opposite over hypotenuse. So sine of theta is 17 degrees is equal to the opposite, which is x, over the hypotenuse, which is 22. And then we'll solve for x. Multiply both sides by 22. Divides out. So calculate it. How tall is the boy? So 6.4 feet, right? So that's 6.4 feet. So if I wanted to know how many inches, let's just say I wanted you to be specific. That is 6 feet, but 0.4 of a foot is how many inches? How many inches are in a foot? 12. So you take 12, guys. Take 12, multiply it by 0.4. And that's 4, right? 4.8. So let's say, he's 6 feet and 5 inches. Okay, 6 feet, 5 inches. Okay. Okay, so now it says, now how far away is the dog from the boy? Wouldn't that be x right here? So now let's set up a different trig ratio. We have the adjacent and the hypotenuse, which is cosine, right? So we'll be doing cosine of 17 is equal to the adjacent, which is x, over the hypotenuse, which is 22. So then we multiply both sides by 22, once again. And so we'll have 22 cosine of 17. So 21 feet, right? Does everybody understand how to do that one? Okay. Pretty easy. Last 2 examples, then you'll have the rest of the time to work. Here we go. A plane is 1,000, so these are the hardest probably for the students to get. So it says, a plane is 1,000 feet above the ground. Okay, so I should have said a guy is in a plane. Sorry, I typed these up really quick. So a plane is 1,000 feet above the ground. As the guy looks down at the airport, the angle of depression is 62 degrees. Find the horizontal distance between the airport and the plane. So let's draw this in pieces. A plane is 1,000 feet above the ground. So here's my plane. Is everybody okay with that? Here's my plane, and it's 1,000 feet above the ground. Does everybody understand how that would be written? As he looks down at the airport, so isn't he up here looking down? The airport must be over here, right? As he looks down at the airport, the angle of depression is 62 degrees. Now, is this 62 degrees? No, eyesight started up here and he looked down. So ding, 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 ding. Right here is 62 degrees, right? Yeah. That was what angle of depression was. Most missed problem on the test. Find the horizontal distance between the airport and the plane. So the horizontal distance would be from here to here. What's this distance? So let's set up a trig ratio. We can't just simply use 62 degrees up here. It's not in our right triangle. But didn't we talk about how this angle and this angle are the same? So if this is 62 degrees, this is 62 degrees, right? And now we can go ahead and set up a trig ratio. So we're going to be using opposite and adjacent, which is tangent. So we'll say tangent of 62 is equal to the opposite, which is 1,000, over x, which is adjacent. Now, pay attention to your algebra. A lot of people from here just get in the habit of saying, oh, so we just divide both sides by 1,000. That's not true. We're solving for x algebraically. We've got to get x alone. X is in the bottom of a fraction. We've got to fix that. So I'm going to multiply both sides by x. Then it divides out. So we have x tangent of 62 is equal to 1,000. And then we would divide both sides by tangent of 62. Type it in for me. 1,000 divided by tangent of 62. You said 53.2? Oh, so 530, I got 531.7 feet, right? Wasn't it feet? Feet. Okay. Questions on that? Okay. We'll read this one, and if you think that you need it, I'll do it. If not, I'll just let you work. So it says, find the angle of elevation of the sun if a 200-foot building is casting a shadow of 47 feet. Do you want me to do this last one? Yeah? Because a lot of you have a confused look. Okay. So it says, find the angle of elevation of the sun if a 200-foot building is casting a shadow of 47 feet. Okay. So if we think about it, okay, so we have the sun, right? So we have the sun, and it says that we have a 200-foot building. So here's my building. And it's 200 feet tall. It's casting a shadow. The building is casting a shadow, right? 47 feet. Now it says, what is the angle of elevation? We know angle of elevation starts from the ground up. So wouldn't that be ding, 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 ding? What's the angle of elevation up to the sun? Does everybody understand how this is the angle of elevation up to the sun? So this is theta, right?
Yeah, it's 47.
47. Thank you. So does everybody understand how this is theta? So then we'll use a trig ratio, opposite and adjacent, right? So it'll be tangent. So we have tangent of theta is equal to opposite, which is 200, over adjacent, which is 47. And then can we solve for theta now by taking, since it's an angle, we take the inverse. So tangent inverse, tangent inverse. So tangent inverse and tangent are gone. We have theta is equal to the tangent inverse of 200 over 47. And then we calculate it.
76.7.
So theta, our angle of elevation, is 76.7 degrees. Okay. Awesome. Do you guys feel comfortable to do those? If you need me to come and check your picture before you actually do the trig, I'm willing to do that. The pictures are drawn exactly how they're set. So draw them correctly. All right, so do the worksheet.